Now let's see what is polarizability, which is very closely related to the electronegativity of an atom or say the element. So we'll again consider our favorite example of water. So we have oxygen, which has got 6 electrons. So 1, 2, 3, 4 and 5 and 6, and you have hydrogen, which has got 1 electron each. Oxygen is sharing 1 electron with each hydrogen, and each hydrogen is sharing 1 electron with the oxygen. So you have a single bonded water molecule which is polar because oxygen is more electronegative, right? It's more electronegative, and hence it attracts more of electrons towards itself than hydrogen attracts the electrons, the shared pair of electrons, and acquires a partially negative charge. Because of that, this side the hydrogen has a partial positive charge, and you see that the molecule, it becomes polar with a negative side and a positive side, right? So this is what we call a polarized covalent bond, or in this specific case it's an hydrogen bonding, but we are considering that the bond is polar. There is a shift of charges which is taking place. So in an ionic bond, we know that a permanently positively charged ion and a permanently negatively charged ion get attracted to each other due to electrostatic forces. So you've got sodium and sodium plus and Cl minus, for example. They are having permanent charges each, okay, but over here there are partial distribution of charges. So chlorine is so electronegative that this chlorine is able to take one whole electron from sodium. It just took that electron away from sodium and got a permanent negative charge. We have something called as electron density. So we've heard about probability cloud regions mostly. So this is the position, maybe this is the position where there is more probability of electron to be rather than this position. So if this is the nucleus, so this electronegativity in a covalent bond is determining the electron density, which is making the compound polarized. So if this is this water molecule, in this region you would find more of electrons going around the nucleus of the atom, and so it's got more of electron density, and here there will be more of the negative charge, that is because of the increase in electron density compared to the the little bit electron density over here. It's very high here, and that makes the compound polarized. So this is happening only when there are two different elements involved in the bond formation. While if suppose you have only hydrogen and hydrogen forming a bond, or you have oxygen and oxygen forming a bond, then they have got similar electronegativity, actually same kind of electronegativities, they have same electronegativities. Therefore the distribution of the electrons is going to be uniform. So in the previous case it was non-uniform, here it's uniform. So just a bit time earlier we had seen what are polarized covalent bonds. So in the to have such bonds, the condition which is necessary, or we can say the reason why these bonds are formed, is mainly because there is a difference in the electronegativities of the elements which are involved. Even the elements will be different, because only then there will be a difference in the electronegativity. But in case of non-polar compounds, there is a different kind of case. So non-polar compounds are formed with the interactions of the same kind of elements. So if you have got O2, H2, all these are compounds or elementary molecules. That is, only one of the element, one kind of a species of atoms is participating in the bond formation. And similar is the case for S8, sulfur 8. So all the similar kind of sulfur molecules are participating in that bond formation. So now if you imagine, see, all these oxygen and hydrogen, these are gases and they are non-polar. So over here, electronegativity is not contributing to making the compound polarized. Rather, if there is more of electronegativity, then there will be less of polarizability, because that particular that suppose this is oxygen, it will be able to attract the electrons more. So there will be less formation of electron cloud regions, or of, there will be lesser displacement of the electrons, and that is what the idea behind the concept polarizability is, that there should be a displacement of the electrons, which will be more if there are more number of electrons, right? So if there are more electrons, there will be more electrons to displace, there will be more electrons, there will be more of charge. So all these things, and because of the more number of electrons, there will be higher melting point and higher boiling point. All these things will change, and this more number of electron will be result of the molecular mass, and as all these things will increase, the polarizability in that molecule will also increase due to the engagement of the atoms inside that molecule, the element which is there. So it's between this, we're talking about non-polar, same kind of element containing molecules which are the same elements. So these core electrons, if they are also more, especially if the core electrons are more, that would mean that there is more of shielding which is provided, and therefore the valence electrons will get less attracted to the nucleus, right? Less attracted to the nucleus, and that is like the effective nuclear charge is quite less. And so if it is less, that means there is more of polarizability. So that also indicates that if the atomic size is more, that means polarizability is also more. So these are some of the things which we need to keep in mind when we talk about polarizability. And now later on we'll be saying how this thing is affecting the state of the matter. Why this is basically the reason why oxygen and hydrogen are gases, and how this is affecting the formation of intermolecular interactions which are affected by this whole concept of electronegativity, electron density, and polarizability. So the intermolecular forces are being affected by this. We'll be learning about this in the future videos.